This video looks at the last technique that we'll cover on differentiation and integration, and it's to do with chain rule. So that's when you're looking at a function within a function, and we'll look at differentiation and integration. So firstly, differentiating using chain rule, we have the rule here of dy by dx is equal to dy by du times du by dx. And what that means is we've got an inside and outside function, or two different functions within the same function, and we have to differentiate each of those first, and then we can get our derivative in terms of x. So our first example is stepped out, and it says find dy by dx if y equals 4u plus 3 and u equals x squared take 4. So the first thing we need to do is we need to do dy by du. So we differentiate this function here, the y equals 4u plus 3, which is 4. And then we do du by dx, which gives us 2x. So then when we do our dy by dx, we multiply the two together. So we'd have 4 lots of 2x, which gives us 8x as our derivative of dy by dx. Now, what we could have done there was substitute into the formula. So we could have made this y equals 4 brackets x squared take 4 brackets plus 3. And then we could have expanded out that to get 4x squared. So we'd have take 16 plus 3 is take 13. And then you can see there that the derivative dy by dx would still be 8x. So we could have substituted it in and done the derivative that way, but chain rule just makes it a little bit more simple by doing the derivative of each thing and then multiplying it together. So what we're looking for is a composite function with chain rule. So it's a function within a function, and you need to recognize that to be able to use chain rule. So we're looking at f of g of x, and we talk about u being the inside function and y being the outside function. So example 2 is y equals 2x take 3 all to the power of 4. So what we're going to do first is we're going to define our u and y function. So we've got u is the inside function, which is 2x take 3. And then our y function would be u to the power of 4. So then I do du by dx. I do the derivative of the first one there, which is 2. And then I do dy by du, which gives us 4u to the power of 3. Once I have that, I do the derivative using dy by dx and multiplying the two things together. So 2 lots of 4u cubed gives me 8u cubed. However, we can't keep a u value in there. We have to have it in terms of x. So we would just substitute our u function back in, which would give us 8 brackets 2x take 3 all to the power of 3. Now, there is a more simple way of doing this sort of one, but it can always be worked out using a u function and a y function. The easier way is if we have something where we've got a function all to the power of something else, we can use this rule here. So we've got dy by dx would equal n, so we bring the power down the front, multiply it by the function, drop the power by 1, and then we also have to do the derivative of the inside function, and we multiply that all together. So we've got our next examples. Y equals 7 plus 2x all to the power of 3. So if we use our rule from before, we bring the 3 down to the front. We write 7 plus 2x and we drop the power by 1 all to the power of 2. And then we also have to multiply by the derivative of the inside function. So the derivative of 7 plus 2x is just 2. And then we can actually multiply that out if necessary. So we would end up with 6 brackets 7 plus 2x all squared. And another one just to consolidate that. So again, we would need to do dy by dx. So we've got y equals brackets x squared plus 3x plus 1 all to the power of 6. So the first step is bring the power down the front and then rewrite the function, but this time we're going to have to the power of 5. And then we also have to multiply by the derivative of the inside. So we would end up with 2x plus 3 on the end. And then all I would do for this one is just rewrite in the order. So we've got 6 brackets, 2x plus 3, close brackets, open brackets, x squared plus 3x plus 1, all to the power of 5. You could expand that first set of brackets out if you wanted to, but it wouldn't always be necessary. So the next step is looking at integration. So to integrate things that are in chain rule, we use this formula here. So we've got a, which is just a constant. Now, the important thing to remember there, it is a constant and a constant only. So it can only be a number. It cannot be a letter. So we use a, the integral sign, f prime x, f of x to the power of n dx. So you'll see there that that part of the equation that is behind the integral sign, that's the full derivative of a chain rule question. So you can see it's got the derivative of the inside function and then also the original function. So to be able to integrate something that is chain rule, you must have the derivative of the inside present. And then once we do that, we integrate as per normal by increasing the power by 1 and dividing by the new power, multiplying by a, and then adding c. So step 1, we rearrange our equation into f prime x, f of x to the power of n. Step 2 is we work out our value for a, and we'll talk a little bit about that through the examples. Step 3, integrate, and then step 4, simplify. So example number 1, we've got dy by dx equals 2x plus 1 to the power of 4. So the first thing that I'm going to note is that the derivative of the inside, so I'm just going to write here, deriv of inside is 2. So what that tells me now, when I have to put it into an integration with an integration sign, I'm going to do 2 brackets 2x plus 1 to the power of 4 dx. But the important thing here is I also need my a value that goes out the front. And to work out that a value, we look at the coefficient of our original derivative. So our coefficient is whatever would be in front of the bracket here. And in this case, there's no number, so it's obviously a 1. So I've just put that in there. So our derivative we have is dy by dx equals 1 brackets 2x plus 1 all to the power of 4. So to get that back to being only 1, because we've put a 2 in there now behind the integral sign, to get it back to 1, we have to multiply by a half, because 1/2 times 2 gives us 1. So now we've done that, what we do is we keep that half sign there, but now we integrate this entire derivative here. So this derivative, 2 brackets 2x plus 1 all to the power of 4 dx, that is going to integrate all together to 2x plus 1 because it goes back to the original function. We increase the power by 5 and divide by the new power. And of course, we have to write plus c. So then what we're going to end up with is if we multiply this whole fraction here by a half, we'll end up with 2x plus 1 to the power of 5 over 10 plus c as our integrated function of that original derivative. Our second example for integration is we've got dy by dx equals 10x brackets x squared plus 5 brackets to the power of 4. So again, we need to write down and note what the derivative of the inside is. So I just write here, derivative is 2x. So then when I'm writing my formula for integration, I'm going to leave a blank space in front of the integral sign for a, and then I'm going to put 2x brackets x squared plus 5 all to the power of 4 dx. Now, our original coefficient of the bracket was 10x. We now have only got 2x. So it means that our a value must be 5 out the front because 5 times 2x gives us 10x. Now, when we integrate, we're going to end up with 5 times, and this here, we're going to integrate this entire thing behind the integral sign to be x squared plus 5 to the power of 5 over 5, because we increase the power by 1 and divide by the new power, plus c. And then if we do that, we end up with 5 brackets x squared plus 5 to the power of 5 over 5 plus c, with the two 5's being able to cancel each other out. So we end up with our final answer of x squared plus 5 to the power of 5 plus c. The last example is just one to show you that we need to check whether we can use the chain rule integration or whether we just have to expand it out. So the first thing again to do, we've got dy by dx equals x brackets 6x take 1 all squared. The derivative of the inside is 6. Now, if you have a look here, the coefficient at the front of this is x. We can't make x from 6. Okay, so this is where if we were to do this and we started it, for example, we would have the integral of 6 brackets 6x take 1 all squared. But the a value that we'd need to try and get it back to x, which is impossible because, like I said before, a has to be a constant. It has to be a number. So what we have to do for this then is we cross that out and we would start again and we would do dy by dx equals x brackets 36x squared take 12x plus 1, which is 36x cubed take 12x squared plus x. So then when we do the integral, we would end up with 36x to the power of 4 on 4 take 12x cubed on 3 plus x squared on 2 plus c, and then we would just simplify. So this is just a normal anti-differentiation question. So we'd end up with 9x to the power of 4 take 4x cubed plus x squared on 2 plus c. So that one there, remember, we just couldn't do the chain rule integration because when we actually write out our formula, we can't find an a because a would need to be a letter and a number, and we can't use that. A is just a constant and it is just a number. So hopefully that's a bit of a crash course on chain rule with differentiation and anti-differentiation. It's just a reminder that chain rule is a function within a function. So you are looking for a composite function to know that you are using chain rule.